All right, so what we are going to be looking at right now is just percent composition. And if you remember, we talked about that this can be used as technically as a form of concentration, and it's not super widely used for this, but you can use it for that. You can also use it to figure out for like mining or oring or anything like that, like which area you should obtain the chemical from. But basically, you're finding out of the whole what percentages of the chemical you care about. So basically, this is by mass because we're doing the percent of the compound by mass, and basically in the whole compound. You can use it to identify substances. You can use it to see which ones are better choices for situations. So the formula is your percent composition is the part that you want, and typically it's an element, but it can be other things, divided by the whole thing, which is the compound. And then since we want it as a percent, we're going to multiply by 100. So what we're going to do is 3 example problems, and then there's a last one that you can try on your own and make sure you're okay with it. All right, so here are some different ones. We want to do the percent composition of magnesium bromide and the percent composition of aluminum sulfate. Sometimes they're going to ask you for the overall percent composition. Sometimes they're going to just ask you for a particular one. But if they don't ask you for a particular one, you have to do all of them. So the first thing I did is I went on my periodic table and I looked up the molar mass of magnesium bromide. So 1 magnesium, 2 bromides. I looked up the molar mass of just magnesium, so I have 1 of it times the 24.3, and I looked up the mass of the bromine, so there's 2 of them and there's 79.9. And then what I did down here is I did my percent of each individual one. So I did the percent of my magnesium, and where these numbers came from is I looked up, okay, just magnesium was 24.3, that's my part, divided by my whole, which was my molar mass, times 100. So only 13.2% of this compound is magnesium. So if I was looking for magnesium, this might not be the place to look. And for my percent bromine, I did the 2 times the 79.9, which is where this number right here came from, the 159.8. And then again, I divided it by my molar mass once again, times 100, and it's 86.8%, which is a pretty large proportion. Over here we have one with aluminum sulfate. The only thing you have to be careful with this one is, again, there's parentheses, so make sure you distribute through mathematically. What I did here is I just did my individuals, so I have 2 aluminums, I have 3 sulfurs, and I have 12 oxygens. These numbers here on the right represent their molar masses from the periodic table. So when I added those all up, I got a molar mass of 342.0. My aluminum then is, again, I just did 2 times 27. I got 54. That's the part I'm looking for, divided by my total, which is my molar mass, times 100. And I am 15.8% aluminum. For sulfur, I did 3 times 32.1, which is 96.3, divided by my total, times 100. And I got my 28.2. And then last but not least, oxygen, I have 192, which is 12 times 16. Divided by my 342, my total molar mass, times 100, and I get 56.1% oxygen. Again, add this up. It better be pretty darn close to 100. Sometimes it's like 99.9, sometimes it's 100.1 just because of rounding, but it should be pretty darn close. You can also do ones, this is actually what we're going to do with a lab, which is our percent water and a hydrate. So this is one of our pretty ones here. And what you're noticing here is we want just the percent water. So we're not doing every element. What we're doing is the specific ones. So what I did here is I looked up just the mass of the water. So I have 5 waters. So I looked up the mass of 5 waters, which is 90 grams. And I did my total mass, which is just my molar mass, is the entire thing right here. And that work is down here, you can see. So my waters, each water is 18 times 5, that's where the 90 came from. And then I did my copper sulfate separately and added them together. When I'm doing my percent water in a hydrate, though, I just take my mass of the water, that's the part I care about. In this case, it's not just an element, it's actually a little formula, divided by my molar mass times 100, and I find out it's 36.1%. So what we're actually going to do on, I think, Friday of this week, we're actually going to do, or whenever you have it, we're actually going to do this in lab, is figure the percent out of the hydrates. And last but not least, problem in this one is sometimes they'll give you enough information that you don't even have to use your periodic table for percent compositions. So we were still finding the percent composition of each one. We're using the information given to us. So they had a compound, they ripped it apart somehow. They figured out they had 2.3 grams of sodium, 1.6 grams of oxygen, and 0.1 grams of hydrogen. So what I did in all these situations is I just used the ratios they gave me. So sodium, they told me I had 2.3 grams. The bottom here has to be the total. So right here you can see I just added them up. 2.3 plus 1.6 plus 0.1 gives me a total of 4 grams. And you can see that for each of these situations that my total is on the bottom. And then what we're able to do from this is we're able to use the experimental data they gave us to actually figure out our percents. And then this is where it comes into using it for identification. So if you know that you have 57.5 sodium, 40% oxygen, and 2.5% hydrogen, you can actually, there are databases, and this can actually identify the chemical. And that's how it can be used for like CSI kind of things. And the very last slide, what you should try is going backwards. So we have a sample of a compound, and we have so much carbon, so much hydrogen, so much fluorine. Try and figure out, go backwards with your math and figure out how much of each element would be recovered from that. And hopefully you feel like it's a pretty good problem.